Welcome. Today, we're not just doing some chemistry, we're actually going to be solving a case, the case of the missing product. Yeah, that's right. We're going deep into a chemical reaction to figure out why the amount of stuff you plan to make and the amount you actually get are almost never the same.
So let's meet our target molecule. It's called ethyl ethanoate. You've probably come across it. It's the chemical that gives pear drops that sweet smell, and it's also used in some nail polish removers. We make it by reacting ethanoic acid with ethanol. But here's the mystery we're investigating. Whenever you do this in a lab, you never, ever get the full amount of product you expect. Something always goes missing.
So the big question, the central mystery is, where does that missing product go? Our mission, should we choose to accept it, is to figure out exactly how much we lost. And we're going to do that by calculating something called the percentage yield. Okay, so like any good investigation, we need to define our terms first, right? We have to be super clear about the difference between the perfect outcome we hope for and the cold, hard evidence we find in the flask.
This brings us to two really important ideas. On one hand, you've got the theoretical yield. Think of this as the dream, right? It's the absolute maximum amount of product you could possibly make if every single molecule reacted perfectly. It's a number we calculate. And then, you've got the actual yield. This is the evidence. It's the real physical stuff you actually end up with, what you can collect and weigh at the end of the experiment.
So let's jump into phase one, examining the evidence. Honestly, this part's the most straightforward. All we have to do is measure the mass of the product we successfully made and collected. Simple as that.
And here's exactly how we find it. You weigh the flask with your product inside, then you subtract the mass of the empty flask you started with. Boom! The evidence is in. Our actual yield is 15.70 grams. That's our first critical piece of data.
Now for the real detective work. To find the theoretical yield, we can't just weigh something. Nope. We have to consult the blueprint for the reaction, the chemical equation, to calculate the maximum amount of product we should have made.
So here's our blueprint, the chemical equation. It looks pretty simple, a one-to-one reaction. But wait, look closely at that clue highlighted on the sticky note. See that double arrow? That means the reaction is reversible. It can actually run in reverse. This is a prime suspect for our missing product, for sure.
Now, this calculation might seem a bit daunting, but don't worry. We can break it down into three simple, logical steps. First, we'll analyze how much reactant we started with. Second, we'll check the reaction ratio from our blueprint. And third, we'll use all that info to predict the max possible mass of our product.
Okay, step one, analyzing our reactant. We need to convert the mass we measured into the universal currency of chemistry, moles. And to do that, we just divide the mass we used by its relative formula mass, or RFM. That's just the total mass of all the atoms in the molecule added together. For ethanoic acid, our starting material, that number is 60.
Let's move on to step two. Here, we check the ratio. Our blueprint, the balanced equation, shows this beautifully simple one-to-one relationship between our reactant and our product. So, what does this mean? It's key. For every 1 mole of acid we put in, we should expect to get a maximum of 1 mole of ester out. It's a straight swap.
And finally, step three, we predict the product's mass. We take that number of moles we expect to get and we just turn it back into a mass in grams. We do this by multiplying the moles by the product's RFM. For our target, ethyl ethanoate, that RFM is 88. All right, detective. We've gathered the evidence in phase one. We've analyzed the blueprint in phase two. Now it's time to bring it all together. Let's compare reality with theory and deliver the final verdict on our reaction's efficiency.
And this formula is how we do it. This is the key to the whole case. It directly compares our real-world evidence, the actual mass, with our calculated ideal, the theoretical mass. We plug them in, and it gives us a single percentage that tells us just how efficient our reaction really was.
Let's walk through an actual case. Imagine we start with 30 grams of acid. We follow our blueprint, do the math, and calculate that, theoretically, this should produce 44.0 grams of our ester. That's our dream number. But the evidence we collected from the flask was only 18.0 grams. So we plug those numbers into our formula. Our actual yield, 18.0, divided by our theoretical yield, 44.0, and then times 100. And the verdict is 40.9%. This one little number tells the whole story. We only managed to create 40.9% of the product that was chemically possible.
So if our yield is only 40.9%, that means a whopping 59.1% of our potential product is missing in action. The investigation isn't over. We have to ask who or what are the usual suspects responsible for this loss.
Well, our investigation points to 5 main culprits. Suspect number 1, reversibility. We already talked about that one, the reaction just running backwards. Suspect 2, transfer loss. That's just product getting left behind on the glassware. Then there's volatility. Our product literally evaporated into thin air. And we can't forget about things like solubility and impurities. Any one of these could be the reason for our loss.
And hey, listen up. Here's a crucial warning for your own investigations. A super common mistake is measuring your reactants by volume. But please, beware the volume trap. See, 25 milliliters of ethanol is not the same number of moles as 25 milliliters of ethanoic acid because they have different densities. So pro tip, always use mass for your starting reactant when you're calculating theoretical yield.
Well, with the verdict in and the main suspects identified, it's time to close the case. Let's file the final report, summarizing the absolute key takeaways from our entire investigation.
So here it is, the final report. Just remember this. Actual yield is what you physically weigh. Theoretical yield is what you calculate. And because of our list of suspects, the yield is almost never going to be 100%. That final percentage you calculate, that is the ultimate measure of how well your synthesis actually went.
Okay, now that you're the lead detective on this case, here's a little something for you to think about. Looking at our suspect board, what is one simple thing you could do differently in the lab to minimize the effect of transfer loss and get a better yield?
Because at the end of the day, that's what this is all about. You know, in chemistry, just like in solving a great mystery, the goal isn't just to get an answer. It's about extracting the most meaningful data you can to understand the full story of what truly happened inside that flask. Case closed.